And she is an associate professor at the Leiden Institute of Advanced Computer Science, where she heads the Programming Education Research Lab. Her work focuses on the question how to best teach programming to kids and students, investigating misconceptions, didactic strategies, and programming environments. Welcome, Felienne. And we also have Federico Tomassetti joining us, who will be one of our panelists. First, Felienne will give a talk, and then after that, we'll engage in an interesting discussion with Federico. And we'll also be taking questions on Zoom and Discord. Or you can also raise your hands on Zoom and let us know, and we'll give you an opportunity to ask your questions. So with that, please take it away, Felienne.
Yes, thank you so much. I'm going to talk about my programming language called Hedy, which is a programming language for children. And before we really dive into the details of Hedy, I want to take you through my personal story of how I came to research programming for kids, because this wasn't my research topic initially. I was actually working on programming for non-programmers, like adult end user programmers, like spreadsheet users. But then when I finished my PhD in 2013, I started to teach kids programming in a community center. So there was this group of kids, they were like 9, 10, 11-year-olds, and they wanted to learn programming. They needed a teacher. So I was like, sure, kids, I can teach you programming, because I thought, how hard can it be, right? They're little kids. They're not going to ask me really difficult questions. This will be fine. But it wasn't fine, because it turned out I really didn't know that much about how to teach kids, right? I knew programming, but I didn't know teaching that well. So these lessons turned out to become sort of a struggle for me and for the kids as well. The kids were like, whoa, teacher, programming is really hard. We're not advancing. It's not going well. And just to give you a little bit of context for the club, what we were doing initially was we were using Scratch. So I guess many of you might be familiar with Scratch. This is what you see here. This is a block-based language made by MIT, in which kids can just click the blocks together and create programs. And this is really nice, because at this point, there's no errors, right? There's never a syntax error, because every program you create is syntactically valid because you click it together. It's like a structure editor for children. This was all fine and peachy up till here. But after a while, kids in the club started to say, yes, teacher, we've seen Scratch now, but this is a toy. This is not an actual language. We know that there aren't professional Scratch developers, right? Sometimes they engage with websites, and then you click inspect source, and you get the sense that programming is textual, so that this is not real programming. So the kids said, teacher, we want to do actual grown-up adult programming. So it's like, sure. No problem, kids. We can just do Python. Python is a very friendly language that has a good community and easy to learn syntax. So this will be really easy. Here, you just type print, and then some brackets, and then some quotation marks, and then you have a string. You see, this is really easy. But the kids did not find this easy. Actually, Python, if you're an absolute beginner, is really, really hard, right? Because if you type print with a capital letter, already there's an error. Then this is hard, because kids have learned that you have to start sentences with a capital letter. This gives an error. If you forget a quotation mark, if you forget a closing bracket, you get this. Syntax error, unexpected EOF while parsing. This is pretty hard. If you put a space in front of the code, one little space that is literally invisible, you get this indentation error, unexpected indent. This was really, really hard for kids. So such a simple program, simply printing letters on a screen, already could break in so many different ways. So I was like, wow, that is hard. Why did I ever think this wasn't hard, right? How did I ever think that this was going to be so easy? Why is this struggle there? So then I started to think, reflect a little bit on the type of things we tell each other in the program community, right? We tell each other explicitly that syntax is easy. This is the story, you could say the lie, that we tell each other, right? It is not about syntax. Syntax does not matter. Language does not matter. When you teach kids, or even when you teach students, it is all about logic. Syntax is irrelevant, because you can just Google syntax, right? You can just Google syntax, not logic. Software developers are just people that have really good Googling skills. So you see, we share, and we continue to share this myth that syntax is easy, that syntax is no big deal. And there was really this big chasm between this story that we tell each other that syntax doesn't matter on the one hand side, and on the other side, kids in my class that certainly were struggling with syntax. So it's like, wait a minute, what if syntax matters just really a lot more than I thought? What if syntax is a big deal? And just to give you a sense for how much syntax matters is I will ask you, presumably not Greek, I had to pick a language. If I ask you to reply to this sentence, you got nothing, right? I can tell you, but you are adults, you can read really well and you know how to read. You can just put this in Google, right? And just look it up. But that's really hard because how do you even type these letters? What part would you even Google? So you see that even if you can read very well, reading something in a very, very different syntax is really, really hard, right? And what this gives you, if you are actually trying to remember all these letters, even though you don't know the letters, is a principle called cognitive load. So if you have to do something for which you have very little prior knowledge, your brain has to work really hard, and we call this cognitive load. Your brain is sort of overloaded, so to say. So when I learned about cognitive load, I thought, that's interesting. How do other fields deal with this, like math or language? How do we, in general, we as a teaching community, how do we make sure that kids are not overloaded by syntactic details? So let's look at what they do in math. So in math, teachers do not say, hey, 3 and 4, you have 3 apples and 4 apples, and you put them together, now you have 7 apples. That's just logic. So you understand the principle. Now we can move on to the next concept. It doesn't matter what symbol you put. This is not what teachers say. Teachers say, here's the concept of addition. And now you practice this symbol a lot of times, like a lot of times, hundreds, thousands of times. You will practice this symbol until it is so easy for you. 1 + 4, 5, 4 + 7, 11. And this syntactic familiarity unlocks the power of making bigger calculations. And if you're still doing 4 + 7 on your fingers, you will never do these big calculations. You really need this syntactic familiarity to be able to do bigger calculations. And the same is sort of true for language. With language, we do not present kids with the entire language of English at once. First, we're happy if kids can do random letters. They don't even have to be connected to each other. Then after a while, we say, okay, little sentences. And then gradually we change the rules. We say, hey, from now on, kids, every sentence starts with a capital letter. Okay, so you practice that syntax, and then you get something new. From now on, kids, we put a period at the end of every sentence. It's like, okay, practice, practice, practice. And then with those new concepts also come new constructs, right? It's not just about syntax, because once you add the period to your library of syntactic elements, you can then decouple the principle of a sentence and a line. For really young kids, a sentence and a line, it's the same thing. Only when you have the period, you can make sentences that are more than one line. So these syntactic elements, they aren't just, oh, now we have this new rule for pure presentation reasons. They also add more power to the language. Like when you can have sub-sentences, you get more power in your language. This goes gradually, slowly. So then let's look at programming education. What does programming education do? I will not talk about everyone, but I will tell you what I was doing with those kids in those early days of my programming class. I would give kids a program like this. Conceptually, this is really quite easy because this prints 1, 2, 3, 4, or actually it prints 0, 1, 2, 3 because we are terrible people. But let's say this prints 1, 2, 3, 4. Right? Conceptually, this is easy for a 10-year-old. It's even a bit boring. But then if you look at all the things they have to get right at once, so they have to learn the concept of a for loop, but also for, I, in, range, which in my language is a really weird word that you wouldn't write like this. Then round brackets, for, colon, you have to go to the next line, mandatory spaces, print, round brackets. This is so much that this is going to give kids cognitive load, so much cognitive load that they can no longer focus on the concepts because they are so busy focusing on the syntax. They do not grasp the concept very well. They have too much cognitive load, preventing them from effective learning. So I was like, wow, that's kind of bad compared to what other areas do. But why do we do that? Why do we present kids with a full language, syntactically perfect language? We don't do that with language either, right? It's like we start them at the real actual language, but we don't have to do that. We could say, well, before you have to do the whole for loop, you can do it, but just without the colon. You just don't put the colon there. And then even earlier, you could say, well, going to the next line and using indentation, this is tricky. You know what? You can just put the whole for loop on one line. No spaces, no new lines. And then before that, you could say, well, for I in range, that's a weird concept. You can just say repeat 4 times. This is closer to natural language and easier to type. So you see, kids start at the beginning and then gradually we add syntactic complexity, but also we add expressive power, because you programmers, you can see that in this first version, you have no access to the iterator. So you cannot do something like 1, 2, 3, 4. And in the second version, you can only do this little repetition because you can only repeat 1 line. But that's fine, right? This is very similar to what we do in natural language, where initially, yeah, you can do really long sentences because they don't fit on the paper. So this language, this is like what I built. It starts very easy and then gradually adds syntactic complexity and also concept. So I will stop my slides for a bit and then I will show you my browser so you can see this in action before we move on with the rest of the talk. So this is the website of Hedy. It's entirely browser-based because we know that schools can't really easily install software on their machine. So it works in the browser. This is level 1. And you see, you can simply run this code, welcome. Let's do welcome rebase. So you see this is actually running. You run the code and it's printed straight away, right? So no brackets are needed, no quotation marks. And just as a refresher, this is what you would have to do in Python. Nothing of that is needed. You can immediately print something. We also want to show like why programming is fun, right? Because just printing something, especially if you're already coming from scratch, is kind of boring. So we also have this ask command, which is like input, and an echo that repeats the answer of the user. So we can say, what is your favorite color? Green. And then it says, so your favorite color is green. So you can already like have a little bit of interaction, and kids build pretty cool stuff with it. These buttons, by the way, are here also a little bit like Scratch, so you can explore what is there in addition to printing text. We also have a little turtle where you can draw with a turtle, make little drawings, because not all kids might be so engaged with text. So this is it. This is everything you can do at level 1. And then we have some built-in what we call adventures, where kids build like a small rock, paper, scissors story or a fortune teller, just to give them a sense of what they can do. Some kids know what programming is and what they can do with it, but some kids need a little bit of help. For example, here, you can take this code, this example code, and use that as a starting point. So the main character of the story is Jan, and then you get this story with Jan. And of course, you can totally customize this. This is just to give kids this, this is where we're going. So this is level 1. Yes, I want to leave without saving my program. If I go to level 2, I unlock a new concept, because in level 2, we get a variable. So we can say name is Hedy, and then we print welcome name. So you get the concept of a variable without any of the syntactic complexity. Again, as a reminder, in Python, you would have to say, this is a string and this is not a string, and then you have to put a bracket there. This is pretty complex if what you want to do is simply explain the principle of a variable. So this is here, you introduce a variable, unquoted strings, and just a variable is there. I will not show all the levels because we have 23 levels leading up to a syntactically valid subset of Python. But I'll just show you one more level to show another transition into more power. And then I'll go back to the slides and then the discussion. Because of course, you experienced programmers, you see that this code that we have here leads to an issue. Because now I cannot do my, your name is name. You would want to do something like, hello, I am seeing that your name is Hedy. This is not possible. Well, actually it works, but it says, oh, well, this should be your. It says your Hedy is Hedy, right? This is an issue. So you see, you run into the limitation of this little language because you cannot distinguish between name, the string name, and name, the variable name. And we actually have a little setup for that. So every level ends with a little what's next that explains, look, kids, we have programmed ourselves into a corner and we have a very limited language. So we say in level 2, you've been practicing with variables. Maybe you've come across this mistake, right? So if kids haven't come across this, we sort of force them to try this out, seeing that it doesn't work. And then we say in level 3, we fix this problem. So if you go to level 3, yes, I want to go without saving. In level 3, you can use quotation marks. You have to use quotation marks because now you can distinguish between what is a variable and what is a name. And actually, we are working really hard on good error messages. So if you do something like this, then it says, hey, you tried to print the variable my, but you did not set it. It is also possible that you're trying to print the word my, but forgot quotation marks. So in every step, we're trying to sort of help kids get to the next level. So that's a tiny demo. But this is all available online, so you can simply go, stop listening to me straight away and go to hedycode.com and try out Hedy. We are available in many different natural languages, so not just English and Dutch, but also German, Portuguese, well, many languages. They don't localize the keywords, but they do localize. I can show you. If we switch to Dutch, you can see that it switches everything to Dutch except for the keyword. So now I get here everything in Dutch. Okay, so maybe you're curious, like, okay, well, this looks really nice. How is stuff going with Hedy? Well, not bad, pretty good, actually. In terms of Hedy programs, since we launched in March 2020, right at the start of the pandemic, we also started, which I think was good because many people were stuck at home. Since then, 1.5 million Hedy programs have been created through our web interface, and over 500,000 of those programs were unique created programs. Okay, many people did, of course, hello world, hello everyone, but there are over 500,000 unique programs that people have ran on our website. In those programs, about 1 in 4 programs leads to a syntax error. And then you might say, well, 1 in 4, 25%. That's quite a lot. However, we know from research that regular languages like Java or Python have error rates for novices around 50%. And the studies I'm hinting at here, they aren't even for kids, they are for undergrads. So even for undergrads that are like older, still the syntactic details give lots and lots of cognitive load. So of course we want to do better, but 25% is pretty okay compared to languages that you would otherwise use for introductory programming. So I guess you're also curious to see not like my demos, but a few demos that kids have made. So I have a few programs here that kids have made on our website just to give you a sense of what kids do. So I have good, bad, and ugly programs to show you before we go to some technical details. As an aside, maybe you're wondering why Hedy is called Hedy. Hedy is named after Hedy Lamarr, a famous actress, but also inventor. So that's why Hedy is called Hedy. Dave is asking in the chat, are those syntax errors? Yes, so these are syntax errors. Those are programs that our parser was not able to process well, or programs that led to valid Python, but then the Python couldn't be executed properly. I have an example of such a program, later in the talk. So some good programs. This is a program where we think, this is pretty good. We are happy with this. This is a program at level 1 in which a kid is creating a little story just by using ask and echo and print. So here you can ask for, the first ask gives this little input pop-up. The main character is Bjorn, and then you get this really nice story. Bjorn is in school and there's a secret about. This is a good program, I think, because it really shows that kids are having fun with programming without doing all the complicated stuff. Imagine if you would do this in Python, you would already need to know variables. You already need to use quotation marks and brackets everywhere. So we're showing kids like, this is something you can do with programming without the hassle, because the hassle will come later. Yes, Dave. Also, Dave is asking, the 50% error rate, is that for the other languages also syntax errors? Yes, these are syntax errors. This is a program at level 2, which I also very much like. Sort of for the same reason as level 1, because this is a kid who's like having fun. Ooh, would you like a stinky explosion? Here it comes. Would you like a poem? They're just like engaging with programming in a way that would be really hard to mimic in this way if it would have been Python. So forgetting keywords at this point is the #1 error. This is the cause of about 20% of our errors is kids forget a keyword somewhere. So they do print, hello everyone, how are you doing? So in the second line, they forget a keyword. This is something that of course occurs in all languages. Actually, forgetting syntactic elements is a very well-known syntax error that we see across different languages. Then over to some bad programs, like bad in a good way. The bad programs will be in the category ugly. So here's a program in level 1 where a kid uses a comma, and that's not allowed for parser reasons. So here we give this error message that I actually very much like. So we're saying there's a mistake on line 1 in position 12. You typed a comma, but that is not allowed. And I specifically want to point out the word comma there. Initially in our error messages, we used symbols. So we would put a literal comma there between quotes to show that it was a symbol. But this was very hard to understand for kids because they hadn't learned that this quotation marks means a literal symbol, because there are quotation marks yet in the language. And also kids are trained to skip over quotation marks and to skip over commas. If you read the sentence aloud, you wouldn't vocalize a comma. So what then happened was kids would say, hey, the error message is you typed A, but that's not allowed. They didn't really understand that that thing there was being pointed at. So this is why we switched our error messages based on an observation study that we presented at VLHCC last week, where we saw that having symbols as symbols is very hard for novices to process. So this is like this is a syntax error, but this is a syntax error like, it's okay if this happens. We give really concrete feedback and kids know what to do. Oh yeah, this is the error where kids are missing a keyword. Here also our error message is okay, right? So we pick the first word. We try to process this as a keyword. It is not a keyword, and we say, hey, it's not a level 1 command. Did you mean ask? So we're trying to suggest a keyword. Clearly here the kid did not mean ask, but we're trying to get the closest word that is a keyword. Here, a kid is in level 2, but using a command from level 1. Here also, I like our error message. We're saying echo is not a Hedy level 2 command. This only exists in level 1. And in the explanation, we also say that at level 2, there's no more echo. So we're also like, it's not bad. If this happens, it is concrete advice. This is a command that's no longer possible. This, though, points to an interesting problem, because what happens here is kids take their learnings from level 1 to level 2, where they're no longer valid. This is our second most common error, also the cause of about 1 in 5 errors. And this, of course, is a Hedy specific issue. This is where we take kids from one level to the other level, and then they should partly forget what they learned in level 1 to use this in level 2. So this is something that our didactic strategy of leveling causes this issue. Then also some ugly errors. So this is an error that we used to have. We have now fixed it, but it's still nice to show you that we are advancing. So initially it used to be the case that if you would forget a quotation mark, it doesn't process the whole string properly. And then it says print is not a level 4 command. Did you mean print? Because there's an error in print, and we try to match the closest keyword that is least string distance, and then you get this. So this is like, there was this little boy in my class, and he was like, wow, this is terrible. I said print, and now it's suggesting print, and this is bad, and I am angry at the computer. So this, of course, clearly isn't as it should be. We've improved this specific error, but we still have many errors open where the error message is just not really good, because the commas and then the brackets are there to help the parser. So we're really creating difficult parser issues with the goal of making it easier for kids. So improving error messages really is an important focus. And people that follow me on Twitter might have seen that yesterday I was working on implementing a type system to make it easier to pinpoint specific issues in which kids are adding a string to a number, for example. So before we go to the Q&A, I want to talk about some of the technical challenges I've ran in when building this. So a little bit of background there. When I saw kids struggling in my class, I was like, oh, I can build a little prototype. I'll just build this little prototype for this one paper, you know, just try it out with a bunch of kids, get a paper out, and then move on to my next idea. But then it sort of caught on and people started liking it, and it became this really like big thing. So there's lots and lots of technical challenges that I hadn't anticipated and that we are running into now. For example, something that's really interesting from a didactic perspective is that we see that kids often use indentation in an inconsistent way. Indentation is really hard to get right. So this is level 7 where we introduce indentation. And you see that line 6 and also line 8 should be indented because both are blocks, the if and the else block. But this is hard for kids. So typically their mental effort, their cognitive load is out at line 7. So they've really focused, oh, it's an if. Oh, the teacher said if there's an if, I need to put spaces there. So they put spaces there. Oh, and then an else. And then it's like their stamina for syntax shit is out. It's over. So then the next line, they forget to indent. So there is like where they run out of syntactic energy. So now I need a custom indenter. I was firstly able to simply use the indenter, but the indenter of the parser framework that we use doesn't allow optional indentation. So either you have indentation or you don't have indentation. You cannot say, well, you may have indentation, because why would you want optional indentation? There is not a use case for this. Either your language is Python and you have indentation, or your language is JavaScript and you have no indentation, like no mandatory indentation, right? It is either or. So now I'm building my own indenter. Okay, this is fun. I will build an indenter. No problem. I can do this. I'll do some manipulation here and there. A little bit of effort, just a bit of effort here and there. Next issue, unquoted strings, right? You know that we have unquoted strings. Who wants unquoted strings? What use case could any parser framework possibly have to have unquoted strings? This never happens. So this isn't supported. So I cannot use default strings from the parser framework because this is always, there's this assumption that there is a delimiter. It doesn't have to be quotes. I mean, you could do brackets, you could do whatever you want, but there has to be a string delimiter. We have not a string delimiter. So this works, right? You've seen that in the demo. Okay, no problem. You know, I simply traverse the parse tree twice, no biggie. I first go over the parse tree, I collect all the variables in my little lookup table, no problem. And now in the actual transpilation step, I know what is a variable, and I simply exclude that from getting quotation marks. This is fine. This is fine. Now this happens. This is a reasonable program, right? Hello, Hedy. This is my name checker. Name is Hedy. Welcome name. This is a program in which initially we generated syntactically valid but incorrect Python, right? Because what we did is just simply checking everywhere if something is a variable, something is a variable, name is a variable. So it would create this first line in a wrong way, and it would just say a name is undefined. This is what it would say. So it would generate Python, we run the Python, and then we see that there's an issue. So what kind of behavior would you want here, right? I think what you would want is name is a string. You would want this to print, this is my name program, and then introduce the variable, like from top to bottom. We tell kids, we read the code from top to bottom. But then here it is a string, here it is a variable, right? So that's not what I want. So now I'm implementing slicing, right? Now I have to check out where this variable is being introduced and only exclude it before the variable. So more and more complexity is coming because I didn't really think of this. And what is so interesting about this is that there's really this tension in this project, all of this that I didn't anticipate when I was building this tiny prototype. There's really this tension between what is didactically desirable and what is technically possible. So stuff like optional indentation, stuff like unquoted strings is didactically desirable. This is what you want. But then it's really, really hard to get that to work because, as I said, we have grammars, we have complicated syntax because computers are not smart and they cannot distinguish between these things. So it's really, really this interesting challenge there. And also in all of these situations, every time I'm making decisions on language design, I have to decide between a didactical solution and a technical solution. So in all of these cases, like for example, with mandatory indentation, you could say, well, we do not do optional indentation. We could do it technically, but we don't want to do it technically. We simply say, you have to do it properly from the start. And if we see that this step is too big, maybe we do only an if without an else, right? We put a level in between. First, we really have them practice only with one block, and then we introduce the second block. So with every choice, every time it is, okay, shall we solve this technically? Independent of can we solve this technically, right? Is it the best for kids to solve this technically? Or is it the best to just explain this to them and have them practice a little bit more? And this is so fun, right? It is so fun because for people that aren't so familiar with my career and my background, I used to work on programming languages way in the beginning of my PhD. Then I worked on software engineering for my PhD. Then I did programming education for a while, but without like any technical components. I really looked at how to explain stuff. And now this sort of brings everything together where I'm both working on languages and also thinking about how to explain stuff, which is just like fantastic to be able to work on those two things. A few more small challenges before we really go over to the Q&A. One other challenge that is of a different kind than the small language challenges that I discussed before, of which there are many, many more to discuss. But like a challenge at a different level is parser frameworks are meant for one grammar. That's what they're meant for, right? You have code, you have exactly one grammar, and then you have an AST and you do whatever, transpiling, doesn't matter what you're interpreting directly, compiling. That's what they're made for. This is not what we have. We don't have one grammar, we have 23 grammars. So this is not what parser frameworks are made for, having a set of grammars that have a relationship with each other. There is some work on programming language evolution in which you have like version 1 of a language and version 2, and there's some relationship, but having a set of connected grammars is just not something that is, when would you ever need it again? So our initial approach was the hackety-hack approach of just copy-pasting the grammar for level 3, level 4, and changing and adding to all the rules. So this just gives you a sense of how the rules are working. This was our initial approach, but of course, if you have many levels, then you get lots of duplication, which you don't want. So now we have this strategy in which every second grammar or third or fourth grammar actually only describes the changes. So it describes new rules and it describes changed rules, but this required me to write a grammar merger, looping over all the grammar, saying, oh, do we already have this production rule in our grammar? If not, then overwrite it. So now I'm like adding this layer on a framework that isn't necessarily made for this. Another challenge, this is also interesting. As I showed you in the demo, we're in many different languages. Currently, we're available in 17 different natural languages, which is really super cool. Like, I love that we're enabling kids to learn programming in their own native language, but this is very hard to maintain. So recently I added a new level 8. In between the old 7 and 8, we saw that this step with for loops was too big. So I added a new level. So now I'm adding this new level in all languages. So something that's a relatively small grammar tweak. Now I have to update all the YAML files for all the languages because otherwise it gets out of date. This is also something I hadn't really anticipated, that many people would use this and that it would really make the language hard to maintain. So now what I need, I don't have this, but now what I need is I need a DSL, right? I need to write a little domain specific language to make transformations to the YAMLs. This is not something uncommon. So I'm sure there's a library here somewhere, but it's just like turned into this massive thing that I wasn't ready for. Some things that we are working on / exploring, and this is also coming back to Arthur's question earlier in the talk. So one thing that we're implementing right now is a type system. So a type system, a Hedy type system. We don't want to rely on the Python type system because the Python type system gives error messages that are not really great. So we want to do better. So we want to gain our own understanding of types in the language so that we have this layer to generate better error messages. Something else, here's your answer, Arthur. We really want to have localized keywords because not our research, but the research of other people has shown, unsurprisingly, this is a paper by Das Gupta et al., that kids learn programming best in their own natural language. So like, I love that they've done this study because it's good to have evidence of that. We also interviewed our own kids, Dutch kids that we work with, and Dutch kids are pretty okay with English because we watch English TV over here. Still, they would also like localized keywords. So this is definitely something we have, but you can see that I already have 23 grammars. Now I have 23 times 17 grammars, right? So even if I would generate the grammars, this is really, really complicated. And if you open that can of worms, have you thought about bilingual kids? You know, do we want to allow kids to do keywords in any language combined? Dutch kids would certainly want to combine with English, but then maybe you have 1 or 2 Spanish speakers. Do you want to also combine English with Spanish? Do you want to combine? This is an interesting research challenge. So yes, we want this. I don't doubt it's better, but it is not very easy. And it will also be hard to maintain. And also, it will be hard for me to choose the right keywords. Even for Dutch, it's really hard to choose the right keywords. What would you do for other languages? Another thing, like this could be a whole talk. Next year at Rebase, I'll do a talk about all the challenges of localized languages. But just like one thing I want to point out to English speakers is that, yes, you could swap out the keywords for other words, but in many languages, the syntactic constructs we have in programming languages do not even make sense. Like in my natural language, you wouldn't say print something. You would say print something out. That's how you would say it. In my native language, you would never say if x is 5. You would say if x5 is. That's the grammatical structure. So it's not just a matter of swapping out words. It's also a matter really of rewriting the order of words. And then my native language, Dutch, is still pretty close to English. Did you know that Arabic doesn't have a verb are? Like there's just no R. They don't have that. They would just say Felienne professor. They don't have this word. So what would you put there in between name and Hedy? They don't have a word. So this is a whole can of worms. It's a cool can of worms though, but it's a can of worms. What we also want, and this is something we're also working on, is this softer language boundaries. So you saw that now in level 1 we have echo, in level 2 we do not have echo. We give an error message. I'm not unhappy with it, but it could be stronger. And well, because I made this merger of the grammars into languages thing, we could also say that in level 1, in level 2 we allow level 1 and 2 code, and then in level 3 we allow level 2 and level 3, but not level 1. So this is something where we're really, we're trying to turn the knob, but again, that is very much a question of, do we do this technically by actually allowing it? Do we do it technically by having really, really clear error messages, maybe even clearer with suggestions? Or do we just say, well, no, right? We could do it and it would be a fun, project, but we don't, because ultimately kids will have to move on to the new syntax. This is true with language as well, right? At one point we want to say, from now on, you simply have to end your sentence with a period. That is the rule. And if you don't, we'll deduct points from your essay. So there again is this super interesting challenge. Okay, one more thing. I promise, I know I keep saying this, but I promise this is the final thing I want to talk about. So I know like Rebase is meant to have this conversation between academics and people from industry. And I just want to also open the discussion, not just about Hedy, but I'm also like really interested to discuss the process, because this stuff like this project blew up, like this is my Git history, right? So in the beginning, I did many things, right? This first bump is like the beginning of the pandemic. And then I was like, oh, I built a prototype. That was fun. And then teachers started to email me and say, hey, we had this Python curriculum and we changed our entire curriculum to Hedy because we think it's better. Here are some issues that we ran into. Maybe you want to fix those issues. So you see then this second wave of, oh shit, this is a thing, and then now it's really big. And yes, yeah, I know. This is just an interesting question. Like, okay, so now I'm literally contributing to this open source project every day. What is this, right? Is this research? Am I doing research? Because I'm exploring so many interesting things, but then is it already research? Does it require me to write a paper about? Is it only research if I write a paper about it? Because like my job is doing research, but actually my job is writing papers. Like, is this research? Is this outreach? I'm building something that is interesting to the community. I'm helping teachers teach programming. Maybe it doesn't need to be research. Maybe it's just good if I am clearly filling a need. I am solving a problem that teachers have. Maybe it doesn't need to be research. Is this professional development, right? Because I'm doing programming every day. Certainly, I have become a better programming teacher, not by just like building Hedy, but just by building anything. And in this case, I'm building Hedy. So I think it's a really, really good and interesting question as a community to discuss. Like, what do we think of professors, of academics, like being very involved with open source? Is this just, do I do this in my free time? Is this my Saturday hobby? Or is this actually part of my job? So I think that's also a very interesting line of discussion we can talk about. The end. So I'm almost in time, right? Oh, yes, I am very in time. So with that, I think we can start the panel.
Well, I would like just to say that before we start answering the question, to encourage the participants to ask their question, to take advantage of this opportunity, because I think that having the possibility to ask a question is great, because we can talk about, for sure, all the innovation you have done with Hedy, but also how you managed to build such an interesting community around Hedy. And we can also benefit from the fact that you are the author of this book, and I should be better finding my camera. So I think that this could be also, a possible topic for discussion. I think that all the research that you've done for this book could be also related to the language design aspects of Hedy, and so I think we should all take advantage of this and ask you as many questions as possible.
Daniel is saying that programmers get lots of attention from the assistance from the editor, like code completion and error markers, but kids and Hedy have to do without. So yes and no. For error markers, this is something we're implementing. We actually have a pull request open at this time. We might merge this very soon. So error markers is not there just because we haven't built it yet. For code completion, we were deciding, like, here's this tension. It is not very hard to build because we have the little grammar, especially in the earlier levels, but that's something where, do we want kids to rely on that? So error markers just there because we haven't built it yet. Code completion is something I would have to think about a bit more, because yeah, the goal, of course, of Hedy is to get this syntactic familiarity where you're like, oh, for iron range. So maybe having code completion there isn't really so helpful. Of course, we do have the palette on the side. So you can pick blocks and have them written for you if you've forgotten the syntax. But the way we implement this now is that clicking the button will completely override your program. So it's really a way to get yourself reminded of the syntax, not a way to build programs. So there we are deciding if that's what we want. This is a great question. Damien is saying, compared to gradual typing, which is definitely something that inspired me a lot, this approach leads to syntactic elements that are no longer valid. Wouldn't a gradual approach consist in allowing the use of old syntaxes with their limits? Yes, this has everything to do with the software borders. Do we allow the programs? There are so many different approaches we could take there that it's just hard to decide, right? You could allow the programs, but give a warning. You could say, okay, we allow it. We run it at a lower level. We just know what Python it transpiles to, but we give you a warning. We could also say we give you a very specialized warning, like you forgot brackets. You have to add the brackets now. So there's really this question whether it's didactically the best strategy to give a warning, to fix. We could also fix the code, right? We could put the brackets there if we see that they're missing. That is very much a question of, there are so many options. We just don't know what is the best way.
Can I ask you something about the internationalization of keywords? Because, of course, we had already a question about that because it's a topic that is very interesting. I wanted to know if you have also noticed that if native English speakers do less error using Hedy compared to other speakers, or maybe if children from countries like the Netherlands, where they speak English much better than we Italians, are having an easier time learning Hedy, or not?
Yes, yeah, we actually did that because we also coming back to Dimitri's question, how do we collect information? So every run on the website, we save the code and we save the information that is present. So you don't even have to be logged in. So we're not like collecting data from kids if they don't have an account. But we do know what language is enabled in the website when kids run code. And to answer Federico's question, we actually see Dutch kids do best. They have spectacularly less syntactic errors than other kids, but we do expect that this is because I taught many of them. So I teach in a high school, and the first few classes were taught by me, and then many other classes taught by people in my team, like my students and my colleagues and people I trained. So we suspect that this is not because Dutch kids are smarter, but just because many of the Dutch kids were taught by me or by my students, especially initially. I think with collecting data for a longer time, this difference should probably go away. I also want to answer Michael's question. So Michael is asking, can you show an Hedy example in which types lead to a better error message? Yes, I will, if you're okay with it, share my screen with you for a bit. So in level 2, I didn't show you this, but then this is needed for the example now. In level 2, we also allow picking something random from a list. And this is also because we want to show like, this is what you can do with programming. So you can create a list and then you can pick a random element from the list. And that allows you to make a fun story, right? Or and this makes a fun story because it's like, you make something like, oh, an animal in the bushes. What is it? It is a animal at random. So where a type system would help is in this case. So imagine a kid forgets these commas. So now animals is a string. It is not a list, it is a string. This is how like we internally process it. Now, this is, animals is simply this string, right? So dog space cat space kangaroo. Python allows this. So this creates syntactically valid Python. If you code, you will simply get a random letter from the string. Because what Python does is it sees a string, it can interpret a string as a list of characters. That's what it does. And then it picks randomly from that list. So this works. And you could say this is expected behavior. Well, it is expected from you. But for kids, this is not expected. So with a type system, we can detect here, because we see that there are no commas, we see that this is a string. Here, once we do a processing of the type system, here we now know that animals is a string. And then we can say, hey kids, you're picking something random from a string. That is not allowed. Here's another ugly example. I'm full of ugly examples. As I said, this was a research prototype that accidentally got out of hand. This is also syntactically valid Python. You create a list and then you print a list. Fine by me. This works. We generate syntactically valid Python. Now you get this. This is ugly, right? This is not what you want, because now you're exposing kids to all of the stuff that they haven't seen before. Here also, we want to throw the error. Based on the type system, we can see that what you're printing is not a string, nor is it a number, but it is a list. We can say, hey kid, you're trying to print an entire list. At your level, like printing an entire list, it has no meaning. When, like in the type of things that kids are doing here, like building little stories, you never want to print the whole list. So these are just two. I have many. Check out our open issues and discussions at GitHub. Here I can show you in these discussions. We have here somewhere a type system with very lengthy description of stuff that we want to do and discussions. But those are just two examples where we believe that a type system is definitely going to help us generate better error message to set better expectations of what kids want or what kids can do.
Yeah, I think also the question from Yusuf is very interesting. Maybe I can postpone my question and that
yes,
one.
I can totally pick up Yusuf's question. Nice to see you, Yusuf. I haven't seen you forever,
Hey,
but I haven't
long
seen
time, yes.
like anyone in forever. Super, it's a great question. So Yusuf's question is like, because I used to work on spreadsheets and how they also help people to learn programming. A live system, a reactive system might make it easier to compare compared to incremental syntax. Yes, this is very true. So something else that would clearly be really, really cool is instead of having this run button that on every key press code is ran and kids immediately see what is happening, but you can imagine that this is pretty heavy processing. Then every keystroke, because this is we do the transpilation server side. So we send the Hedy program to the server, we transpile it there, we send the Python pack, and then actually we use a JavaScript library called Sculpt to run the Python in JavaScript. Felienne, a question. Why don't you transpile directly to JavaScript? This is a great question because I didn't expect this project to get out of hand. So if we would do transpilation on the client side in JavaScript, then maybe such a live system would be possible. But now with the server architecture that we have, this would be very hard. But I agree with you. And this again is this tension. Didactically, yes, it would be really nice to see when the program is breaking. Like you put the space in, you put the quotation mark in. Oh, now it breaks. Yes, that I truly believe didactically that would be better. But then now I'm overhauling my whole architecture. So yeah, it's not happening soon, but it's a good idea.
Thanks.
Can I ask you a question about the difference between how children learn and how adults learn? So people that learn programming at the university or later in their life, are they learning much differently than children?
Yeah, that's a great question. So in general, we know that beginners sort of do, at what age, it doesn't matter what age you're a beginner, beginners learn the same. So there is certainly a threshold. Once you know a bit, then it gets easier to learn other things. And this is also why we say syntax doesn't matter. If we all now pick up a new language, like I was learning Rust a while ago, then for me, syntax matters less. I wouldn't say it doesn't matter, but it matters less because I can see through the code and I know, oh, this is an if, this is a loop. But in the beginning, beginners always sort of have the same issues, and it doesn't really matter. One thing we do know from adults is that the older people get, the more scared they can sometimes get about making questions, asking questions and about making mistakes. And they can get more self-conscious. Maybe they think like older people might think they're too old to learn programming. So this is an interaction that you can have if you're learning programming. If you're a bit older, then you think this is also why error messages can be really detrimental, like the type of super confusing error messages I showed you in the beginning. If you're the type of person that thinks programming is going to be really hard, right? They come to programming class and go, oh, programming is going to be really hard. And then you forget a bracket and the thing says syntax error, unexpected EOL. Then you're like, yeah, programming is hard. Never mind. I'm going to do something else with my free time. So this anxiety, that's definitely something we see at a later age. Aviral has a question, really nice question. Have there been studies that have investigated the impact of syntax? Yes, this is really nice work by Andreas Stepik. He wrote this fantastic paper about a programming language called Randomo. And it is what you think it is. This is a Java version with random keywords. So instead of Java keywords, they just swap out every keyword with a random character. And they did a study, and then this random language of theirs, it does better than Java. I think they compare it to many languages, it does better than Java, Perl, but it does worse than Python, something like that. So yes, these studies have been done. So the impact of syntax is sort of confusing. On the one hand side, it doesn't matter because everything is confusing. But on the other hand, there are languages like Python that definitely do better than randomly generated keywords. Your second part of your question is, do you think it will be harder for kids to learn programming in Lisp syntax? So here it is time for me to start my traditional Lisp rant because I like ranting. Lisp is so interesting. Lisp is so interesting because people say that it has no syntax, which is only true. It's like only true in the same sense where we say that syntax doesn't matter. So for us, it doesn't have syntax because you're directly manipulating the AST. But of course, for kids, certainly it will be harder because there's much syntax, because you have to put the stupid brackets everywhere, which you never use. So this takes much energy. So I don't doubt that it will be harder for kids to learn programming in Lisp syntax because they're doing something that they have never done before, like grouping stuff with brackets. If you're 10, 11, 12, that's not a construct at all you are familiar with. This is something probably you haven't even learned in math class. So depends on where you live, of course, but in my country, kids would only use brackets in math for functions when they're like 12, 13. So it is something that is very alien to them. This is why Hedy picks this natural language start, because that's something that isn't so alien. So if brackets are alien, then it's really going to be really hard. If it's not, like for us, yeah, then it might be easier because then you're not distracted by, well, here's yet another thing I hate with great fire. You're not distracted by syntactic sugar, right? Like syntactic sugar, like syntax isn't the most important thing. Anyway, I think, yes, don't teach your kids using Lisp. They will hate you later. Dave is also so many interesting questions coming in. Dave is saying, you can't observe the value of this thing because it's a list. Sounds like the sort of thing that makes programming harder to learn. I don't know. Like, this could be an interesting study that we can run. We don't have this error message now, so we don't have data to compare yet. However, I think in the scope of level 2, right? We're not at level 12 or 22, we're at level 2. In the scope of level 2, it's just not a thing that you're doing yet, because you're storing variables, you're storing lists only to pick something random from them. That's the trajectory that we set out there. So I don't think it makes programming harder to learn, because I think in the type of things that at that level we are offering, it just doesn't make sense to do that. And Michael is adding.
It's okay to give people that error message because they're not going to do it anyway?
No, because didactically at that point, we are not teaching them that use. So there isn't going to be a really good story. There isn't going to be a really good use case. And of course, if you're in a room where there's also a teacher, right? We don't envision people use this without teacher. Nothing is really good to use without a teacher, I guess. A teacher could say, hey, I see that you're trying to do this later, in later levels, this is something you could do. But then you also need to present them a really good use case, because why are you printing a list? And I think Michael is making a really good point there, that you might be printing a list when you're debugging. This is a really good context in which you're printing a list. But at this level, that just hasn't occurred yet. So I think I can say with confidence that in the way we are teaching Hedy currently, it's almost certainly a mistake. It's almost certainly a mistake of the type that I showed you, where what is actually happening is you're forgetting commas. That's the real issue there. I don't think there's many situations in which what kids want is to inspect the whole list, because that's just not something they've seen yet. Of course, as I said, they will see it later. But it's interesting, right? I also don't know if this is true. Maybe this error message will not be helpful. Maybe, again, boys will be shouting at me saying, this is a terrible error message. I wanted to see what's in the list. This might be true. Like, this is research. I don't know for sure. This is just my best guess based on what I've seen so far. Oh, so many nice questions. Can I pick up another one, Federico, from the chat?
Yes, please. I will add myself to the queue.
That's okay. Arthur is saying, yeah, you said earlier that children tend to read their code from top to bottom. Do you think introducing non-imperative programming or asynchronous programming falls in the scope of a tool for beginners? Or is it something to approach once you're used to the basics of programming? This is such a deep question. In Scratch, for example, you have asynchronicity from the start. You can even have parallel scripts, right? You can just put two blocks next to each other, and if they have the same event, if both of them are like when space pressed, then they both fire. This can lead to super confusing behavior, because if you have race conditions in between the two stacks, then you get issues, but you can do it. And also they have this asynchronicity where basically everything is like a game loop. It's like when the space bar is pressed, an event happens. So I definitely think this is possible for kids. However, once you move to a textual language, not necessarily Hedy, also Python or Java or whatever, then you go towards initially reading from top to bottom. And this is also already for any language that isn't Hedy, right? We're already doing this gradual teaching typically, because if you teach Java, probably initially you will also teach your students code is processed from top to bottom, because they have to understand that in principle, first the A is 1, and then if you have an assignment later, A is 12, then first it becomes 1 and then it becomes 12. So you always have to teach this, it goes from top to bottom until this breaks, because then you have a switch, a case statement, and then it's like, yes, it goes top to bottom, but only one of these two. And then you have a loop, and then you say, well, your execution pointer now it goes upwards, it goes like backwards, so to say, and then down again. So these are already lies that we tell students, even independently of Hedy. So I guess this is just the inherent limitation of current textual languages, is they tend not to be asynchronous, and they tend not to have threads readily usable. But of course, there are some languages, some more modern languages that do have that, and then you have to think, what is the best strategy there?
And can I ask you something that is related to Scratch? That if I remember correctly, you said that at the beginning you show Scratch to the students, but the students look at it and say, okay, this is not programming because the professional do something else. But do you think is this somehow limiting ourselves in what in the notation we can use, in the approaches we can use, because we have this preconceived idea of programming, and so yeah, it must be like this, or
Yeah, that's a great question. And clearly people that are familiar with my earlier work on spreadsheets know that this is a fight I have fought also for spreadsheets, where people also would say spreadsheets aren't real programming. So it's really sad to see kids adopt that notion, and especially in Scratch. So by the age that kids get sort of bored with Scratch, didactically, there's so much still to learn in Scratch, because you can create your own blocks, which is really pretty powerful. And then there's Snap, which is like Scratch for older kids, that really has like blocks as first-class citizens, where you can create a block factory that outputs a block that you can then map over a list. It is really like Haskell, a Haskell structure editor almost. So there's much to learn, but at a certain age, kids resist this notion that it looks like a toy. Not always, but sometimes encouraged by parents, often dads that are programmers themselves, right? They would come into this programming club and they would say, you have to teach my son a proper programming language. So it isn't like they get this notion. Partly it is growing up, and if they have a younger sibling and they see the younger sibling is also using the same toy, then this makes them not want to do the toy anymore. So that's definitely a reason. Also in the Netherlands, we have a different school system than in the US. So we have elementary school until 12 and high school from 12. In this switch from elementary school to high school is also where Dutch children are like, okay, now I'm a grown-up. So that age also that they want to do, they don't want to do things, that is also elementary school stuff. So that's this specific issue in the Netherlands. So there's this general notion that you don't want to do stuff that looks like it's small, but there's also really this notion that programming parents might encourage this, might say, oh yeah, Scratch is fun, but it's not the real thing. And as I said, also more and more kids, of course, are on the internet trying out stuff. So doing something like inspect source or inspect elements, seeing that what is behind the web, which for them, the web is programming, there's not really a good understanding of the difference. They see that what is behind the web is not Scratch blocks. It is letters, it is code with syntax. So there's, in essence, this is also an opportunity, right? They want to learn. You could also, and I'm phrasing it very negatively, you could also phrase it more positively. You could say there's really a didactic opportunity because they're really motivated to learn our weird ass brackets. They really want to, right? Because they were like, oh, now I'm one of the big boys or girls. So they want to, but then it turns out to be too hard. But you're really right. I mean, there's no reason why they couldn't do Scratch and then Snap and then go straight into low code, no code. Why are we still typing? This is an interesting question that I think from way before I was on this planet in the 80s, we were already figuring out, like trying to figure out like why are we manipulating a text-based AST? Why aren't we just really not even in a Lispy way, but in a structure editor? Why aren't we doing that? I don't know why it keeps failing. I really don't know. I don't know why. Like Scratch is maybe the most successful example of a structure type editor. Well, there is MPS, but I love MPS. It's not really mainstream, right?
Yeah, definitely not. No, but it's interesting, this strict definition that we have of programming. So if you ask someone to write tests, they answer you, I'm not a developer, but they can write some very complex expression in Excel and say, okay, I'm fine. This is not programming. So it's a bit strange. But I think that will be really interesting to discuss if there are some lessons that you have learned while building Hedy to make languages easier to learn or easier to design. So do you think that there are lessons applicable to other programming languages?
Yes, for sure. So I think this gradual approach of onboarding is definitely something that could work for other programming languages as well. And I really like small things you can do in your own code base, like having optional parameters, for example. Imagine you're building something like an API, just allow people to create an object without many of the parameters, even though you might think, well, it's probably best if they set this parameter. And you could say, oh, there's this easy way of using it so that at least you can use it and nothing breaks. And then here are maybe 5 other versions of the constructor that you can use with more parameters. That's just a little bit of like gradual thinking into designing. Well, I would say an API is a UI. So we're designing a UI for your users. In any case, having small examples wherever possible, if you're describing your programming language or your library or your framework, have examples that really first show the essence of a concept. Maybe also in syntactically, I don't want everyone to build their own little parsers and grammars, but you might just have examples that highlight, this is the concept without all the syntax, this is the concept. Right, and then just being able to manipulate that in a way, or just see it, and then add the syntax. That separating, explaining the concept. I just mentioned I was learning Rust, and Rust is both syntactically quite a bit different. It has some of those weird, like the borrow checker, HTML triangle bracket stuff everywhere, but also conceptually really hard. And I really, of course, now I'm looking at everything with my Hedy glasses on, right? So I was like, well, it would be nice if I could learn the borrow checker without the syntax. And then in all code examples, I'm always presented with wicked weird ass syntax I am not used to, and also concepts I am not used to. So there, in learning this language, I really thought, well, you could teach those things separately, even though I understand you don't want to build a Hedy-like syntax-free borrow checker. This would be not fun, but still you can present examples where you really say, okay, we're explicitly not now focusing on the syntax. We will deal with the syntax later. I think that would be good advice for everyone teaching, even if you're not implementing something.
Okay, just a note from the organizer, we should try to finish 5 minutes early to leave time to switch the room. So let's take advantage of the next 10 minutes or so. And in the editor, I also found very interesting this palette you had on the left. So I was wondering if is an idea that you have from the beginning, is something that came up from feedback, or do you think it's applicable to other languages, like maybe while learning Rust, for example, having the possibility to see, you know, what you should learn next and have a reminder?
That is a great question. So the reason we have it is really coming from scratch. So kids coming from scratch, they are used to always having this repository of things that are possible. And I think any editor could have this, right? Even a beginner like idle for Python, a beginner Python editor could also have a palette, could also say, oh, assignment, for loop, while loop. It is a bit like having autocomplete right there. But the difference, I think, between a palette and autocomplete is autocomplete helps me if I almost know what I want, right? I know I want while, but then I don't know what the rest is. So I type while, then I hit Alt Enter, and then the rest like pops up. But if I really don't know what I want, being able to browse the blocks or the snippets is really nice. So I think this is in general very, very helpful to have code examples there that you can run always in the editor. Because stuff that I talk about this in my book as well, like interruptions are expensive, not just for kids, also for adults, like going to Google and looking something up, like separately from the time it takes you to actually find a proper answer, even just going there, being out of it breaks your flow and then you can get back in. So having code snippets in the editor, I think this is a relatively simple thing to have. Of course, Hedy makes it easier because our language is small. In the first level, you say this is literally everything you can do. And actually, we're experimenting a little bit with some UI changes where at every level we really have all options that you can use. So I think also this is something. Hedy makes it slightly easier because our language is small, but in general, many editors, especially editors that are made for kids, could have these demo programs. One of the other things that we're working on is if kids are really stuck on a program, to just give them a sample program that has more or less the same keywords. That's something so we see that sometimes kids just keep clicking the run code button and the code isn't working and they're not really making changes, or they're making like tiny changes. Clearly they're stuck. We're thinking of having this repository of canonical programs where we just see, oh, you're doing something with ask and print. Here's a program that uses ask and print that is syntactically valid. Now you can just change that. Like having example code is such a good way. I don't know, maybe this is me, maybe you're all different programmers, but if I am learning a language, I want to have code that's working, that looks like what I want, and then I can just change the relevant parts. So offering example code, I think, is a really good way to help get unstuck. And such a palette is relatively, from all the stuff that I built in Hedy, the palette clearly wasn't the hardest thing to build. Pretty easy. Yeah. Although it is now hard because by now you have palettes in 17 languages times 23 levels. So now that is also hard, but in principle, it's a simple thing.
Yeah, I personally would love keep talking about tool support, but I think that would be really important to talk also a little bit about the community. So you have built this very successful language, if I remember correctly, 1.5 million programs, 500,000 unique users, 17 languages supported. So can you tell us a bit more about how you manage to involve these people, and maybe also how people can step up and try to help?
Thanks, yes. So in the beginning, I don't know. So really in the beginning, I don't know how people found us. Of course, I'm on Twitter and many people follow me on Twitter. So people got involved that way. From the beginning, we did have Dutch and English support because I wanted to use it with Dutch kids. So we had the whole infrastructure to have 2 languages. Would I have been an English speaker? We would not have 17 languages, we would have 1 language. And this would have been like, oh, it would be nice for other languages, right? So we had this architecture from the beginning. Initially, people started to contribute mainly in translations. And then we built we have translation UI, where if people want to translate that are teachers, they do not need to translate the YAML files. They can translate all the files straight in the browser. That is really helpful. So that really helped to attract more translations. Initially, we had many like drive-by contributors that would just, I don't know how they find repos. They just fix an issue, they commit 1 pull request, and you're like, thank you for this. Can we send you a Hedy sticker as a thank you? And then they never come back. That was still, I mean, I'm so grateful for everyone that's helping. But then what we're having now, we're getting more and more really long time contributors that are often contributing. Some things that we're doing that's definitely helping is we have many issues that are labeled good first issue. And I know for a fact that at least 2 of our common contributors came in, saw an issue that was actually easy to do, that was labeled good first issue. They did that, and then they like started onboarding, and now they are part of the core team. So that's definitely something I found that really, really helps. But also, yeah, I spent lots of time. If people are contributing, I do. We have Hedy coffee mugs. I've shipped Hedy coffee mugs all over the world to people that have translated, that have given us feedback, that have taken the time for that. So that it's not very expensive to make a bunch of coffee mugs, but it is very much a gesture that is helpful. So initially it sort of happened, and then now I'm really making conscious effort to keep the GitHub very up to date. Initially, clearly, I was simply committing to main, right? And never talking with anyone about ideas. Just, okay, just a new level, notifying no one because I didn't know how to even notify people. Now we really have this discussion that I briefly showed in GitHub, where we are discussing new features. We are announcing for teachers, beware, changes are coming. So I'm really trying to run this as a serious open source project. But then also it's interesting because I am not a programmer. And as I said in my slides as well, I really don't know. Is this my job? Is this still my job? Like, I have tenure, so partly I can do whatever I want that I think adds value. I certainly think this adds value, but it is really interesting. Like, is programming, even the difference between me writing Hedy myself and me maintaining this living beast. Like, I sent this tweet like a few weeks ago. I went on vacation for 1 week, 6 days, from Tuesday to Sunday, and I come back and 21 pull requests are waiting for me. I'm like, come on, guys! I was on vacation for 1 week, so it is interesting. Is this even my job? Should I even be doing this? I don't know. I'm just trying to do my best. Yes, yeah, I know. Philip sent me this paper, Camille, because I was in an email exchange with Philip. Like, how do you do this? I need help. And then we chatted a bit about his Python tutor, because I think he had a similar, even bigger. I mean, I'm sure Python tutor is way bigger and more often used than Hedy is. So he had a similar different issue.
I think this would be this might be a good time to end this talk. It was a wonderful experience, but we have a next talk starting in 6 minutes, so we should give our viewers a break between the two talks. But thank you, Felienne. Thank you, Federico, for joining us.